So just like the previous question that we looked at, right? 3 mark questions. This was what? This was 3.3, right? Of whatever this was asked. It was asking for alpha. But then anyways, what did we say here? Question. Wait, oh, yes. Wait, so question 4 doesn't have a sketch.
No, the sketch is that one on top. The one that is the.
I'm seeing question 5 down here. Let me crop it out so that I don't get confused. Okay, so if it's a 3 mark question, right? And it's like kind of deep into the question because it's like question 4.5. So
Yes.
4.1, 2, 3, and 4, right? All these, they basically you basically need to make use of them. One or the other. Not like all of them, but probably some of them. Some of those questions. So Q, what is it asking for here? OS. Oh wait, if OS is this, so OS is, wait, let me just see the description. In the diagram, P is this, Q, O, and S are vertices of a parallelogram. Okay, this is where we're gonna get the chunk of our information. It's a parallelogram. Now, as long as it's a parallelogram, as you already showed here, right? You have parallel lines there, and then this is equal, and then also these are equal. So it's like a gang load of information. Now, it's very easy to underutilize what we're given. So they gave us OS. They gave us the distance of OS, meaning they automatically gave us the distance of QP. And then they said here, you have the equations. They're defined by the equations y is equal to 6x. So the y is equal to 6x, it has a positive gradient. So this is the one for OS. This is the one for OQ. Okay, so this one is quite important. Okay, no, both of them are important. You know, they're all useful. So here, let's see, to calculate if OS is this distance, calculate the length of QS. And then QS, what we need to remember about QS, well, I mean, there's nothing to remember really. It's all in our faces. QS is this line over here. So I think maybe because the year is still a bit fresh, there's a lot that you guys haven't learned yet. For example, you haven't learned the area rule or things like that. You haven't learned these 3. Area rule.
My teacher haven't taught me. I only know about the, what do you call it? The area rule? I think I learned it because of that course of yours. And then
Yeah,
it
so
really ended there. My teachers didn't
okay.
yeah.
Yeah, so the area rule, and all these 3. Let's actually even go through them nicely because you kind of need them. So, but the thing now is, I'm asking myself, if you're doing analytical geometry now and you haven't learned these, okay, well, maybe because this is like from a past paper, it's almost gonna assume that you know everything. So it's fine because in this triangle, right, we kind of have a lot of information to work with. Do we have OQ? OQ, we can work it out if we needed to, because we have the coordinate of Q. Do we? I think at some point you got Q, no? So if you have the coordinate of Q, you can already see that in this triangle, you can work out the distance of QS using of OQ using Pythagoras. Because if this is like -5, it means the distance here is 5. If this is 5 is the y value, it means the distance here is 5. So do you see you're easily able to work out OQ? Oh yeah, they asked for it. And it's not a coincidence why they asked for it. Because now if you have 2 of these lines, the lengths given. So here they told us it is square root of 148. What is the distance here that you got? Square root of 50.
For number 4.3.
Yeah.
4.3, I got 2 square root 37.
Whoa, 2 square root 37. That's a bit weird. Are you sure that was the answer?
What? Oh no.
Yeah, because it's like it sounds a bit shady. Because I mean, like, yeah, if you have if 5 and 5, right, we're gonna have like 5 squared
Oh,
plus 5 squared
okay.
is equal to all
Ignore.
q squared. You see?
It's oh,
Yeah,
okay.
this would give us something totally different. This is like 25 plus 25, and then if you square root both sides, you'd have all q is equal to square root of 50. You see?
It's okay. It's 5 square root 2. My bad.
5 square root 2. Yeah, because 2 times 25. Yeah. So yeah, that's the length here. Let's just put it in green so that it also pops like the others. 5 square root of 2. So you see, we have a length here and a length there. So the fortunate thing is, like, depending on, you see these three things that we mentioned here: area rule, cosine rule, and sine rule. These are more like three specific formulas that you somewhat learn this year, and they are quite useful for triangles, especially triangles that are not right angled triangles. So for example, the area rule, all these formulas, right? Let me just draw out what kind of a sketch you would have. So the idea is you would have, you see here, a triangle. Aibo. You'd have a triangle, right? Now this triangle, the different names of the angles, you could have here A, B, and C. So the issue is any side that is directly opposite an angle. If this is B, we have to call this one small b. If this is C, we have to call this one small c. If this is A, we have to call this one small a. So the idea is with the area rule and all these other formulas, it's all depending on which values of your shape do you have, whether you have the angles or the sides or whatever, it doesn't matter. It's all about seeing what you have and what are they asking for. So for the area rule, this is what the formula looks like. The area rule formula looks like a half multiplied by A multiplied by B multiplied by sine C. Now the image to look out for when you're going to use the area rule is a scenario where you have the angle given here and you have the side given over here and the side given over there. You see, these two sides have to be given. Or let me use this sketch. Let me do it like this to make your life a bit easier. Let me use the sketch that we have drawn there. So if you look at the sketch that we've drawn, this is angle C, right? So if you have angle C given, you also need to have this side given and this side given. As long as that's all given, you can then use the area rule, because you can see here, this is saying A, which would be here, B, which would be here, and then the angle C. You see the angle has to be in between the two sides there. Do you see it?
Yeah.
Yeah. So the fortunate thing is the cosine rule is literally identical in terms of what you need to look out for you to be able to use it. The cosine rule is a bit long, but it's not that difficult to remember. You just have to think of Pythagoras first, because it's something like this: a squared is equal to b squared plus c squared. This is Pythagoras, right? But then to this, you're gonna put here -2 with these two pasted together individually, and then you're gonna put cos A. You see, so you can already see with the cosine rule, the only thing that's new is this. You see, where this will always remind you that, okay, those are the two sides that go here, and then this will always go according to what this is. You see, so, and the other issue with this specific sketch, with this specific formula, is that the sketch needs to have this same scenario playing out, where if you need the angle here, let me label this A, right? If you need the angle here, which will be like A, or if you need a side or whatever you'll need, your sketch always needs to have this format where the angle is in the middle and the side is here, the other side is here as well. See, because if you look at this image, you see here you have B and C, and then over here you have A. So you can use this formula to work out any missing variable depending on what you have. But then you can already see the cosine rule is a bit demanding. You know, you literally need to have a slot for everything, and only one thing needs to be missing. You see, so that's the cosine rule. The last one is the sine rule, which is not so bad. So the other thing also is, you see how this is like still brand new. So you seeing it now, I mean, like, you don't want to take it too seriously because it's for the first time. So it's just you seeing it for the first time, which is fine.
Okay.
The sine rule basically states that if you have a side opposite sine the angle, it'll always be equal to the other side over sine the angle, which is also equal to side over the sine the angle. Now the good news is that all this can be swapped around. You see, depending on what you need to work out. If you need to work out the side, it's easier to put this on top. If you need to work out an angle, it's easier to put the angles on top. It's not like a rule to say you should use this on top, blah, blah, blah. No, it's more for convenience. You see, if you need an angle, it's better to put the sines on top. If you need a side, it's better to put like the sides at the bottom. And the other thing is, these are only used two at a time. You see, you only use either this with this, or this with this, or this with this. You see, you cannot use all three at the same time. It just depends on what information you have. Now, in terms of the information that will be compatible with using these formulas, if we have here A and then B here, then C there, then you want to keep in mind that all that needs to happen is, remember, if you're going to use two at a time, can you see you have like 4 variables? 1, 2, 3, 4. So obviously 3 of these have to be given, at least 3 of them. So if this is given, given, and given, then you can see they're asking for B. Now you can already see if they're asking you for B, you at least need to have the opposite side, and you need to have at least a complete pair, either the A angle and the A side, or the C angle and the C side. It doesn't matter, as long as you at least have one full thing complete. So here, if you have A and you have small a, then I mean, you're good to go. You see, you'll be good to go, because you will then be able to throw in an angle there, and then you'll be able to throw a side over there. You'll be able to throw a side over there, and then you can easily work out the angle. You see it?
Yeah.
Yeah. So with our question, it's the same idea. The fortunate thing is, if you're looking at our triangle here, you can see it's not very crazy. What did we get as alpha?
Alpha I got 54,46.
54,46, 54.46. So that's the angle there. Now, as you can see, we have an angle in the middle, and we have sides on both. We have the angle with the side. We have the sides given here on each side of our angle. So you see, this sketch here looks appropriate for us to work out the length of QS using the cosine rule. Because if you think of the cosine rule, remember the cosine rule says we need to see a sketch like this. You see, where there's an angle in the middle and then 2 sides given. And then we're looking for the one on the opposite side here, which is exactly what is going on here. We have the angle, these 2 sides, and we are looking for this. You see it?
Yes.
Yeah. So the only thing to remember with the cosine rule is that the angle here, I mean the side here, just goes with the angle there. See, so if you're looking for the side, you need to make sure that you have this angle. If you're looking for this angle, you need to make sure you have this side. You see, so if you have both of these, then it means you're either looking for B or C. You see, so over time, I mean, it's a formula. It's not something that works against you. It's something that works for you if you give it like the correct data. So in our question, let's see what we can write down here. So let's just see. Let me write it nicely. Q or S. So we have Q or S here. Let me just copy it. I'll make it a bit bigger also. And then we can just use the cosine rule for the first time, so that you can see how useful the cosine rule is. So I mean, like the main gist of all we're doing here is to show that, okay, now you have formulas that can work stuff out if you're not dealing with a right angle triangle. So we say the main issue with the cosine rule is this side and its opposite angle. So putting the formula, we can just put the QS squared is equal to 1 of the sides squared plus the other side squared. And then these two pasted together next to a 2. And then cos the angle opposite this one. Do you see?
The angle opposite of it.
The opposite the angle opposite the side. You see here we have QS here. As long as this is whatever this side is, the angle here is the one opposite that side. You see, just like what we said here, whatever this is, this angle is always the opposite angle. So to put in our information, we're gonna have here QS is what we're looking for. OQ is 5 square root of 2 squared. OS is square root of 148. And a 5 square root of 2 here. Square root of 148 here. And then 54.46, you said. Whew. I did not give myself enough space. Uh-oh. Okay, so let's see here, 54.46. So the first thing you can clearly do is put everything on the right-hand side under in the calculator, or we can just do it all at once. We can just square root both sides. So if both sides are square rooted, we're gonna have this here. And then what do we get for that?
I'm doing it now.
Thank you. Let me know what's up. You let me know what's up.
Minus.
Yes. So what did you get? Oh, you're still putting it in the calculator. And like OE. This thing's still connected. Yep. Oh, before the square root.
No, you see, I can you calculate the things. So if you calculated the first part, right? I'm separating them. Like I got the answer for the first two, and then minus
you mean this
that other answer, and then I got 97. Oh, am I wrong?
Is that what's under the square root? The whole thing here?
Yes, the whole thing.
Okay, and then if you put it under the square root, what's the final answer?
Wait, I haven't been getting confused here. I'm saying when I calculate it, yeah, it's okay. So square root 97, square
Oh,
root
that's the answer.
97,9943,
Oh,
right?
this is
And
the
then
answer
when square
basically.
rooted, it's 9,899. And if you round it off, it's 9,9.
Okay, so it's approximately 10.
Yes.
Yeah, that's kind of shady. But we might as well keep it like this
Oh
because
no, the final answers thing, the 9,9 is the final answer. That's when you round it off, the 9,9.
Okay, then it's fine. So that's the answer for QS. What does the back of the book say?
Wait. Yeah, same thing.
Nice, nice, nice. I guess life is good. Life is good then. Yeah, so I think that's that then for this question.